Hello, in this video I'm going to be going through the Unit 3 practice exam, which is all about the atom. So the things that you need to be familiar with, look through the history of the atom, make sure you know the different models and the different scientists and all of those things. Additionally, you need to be familiar with the subatomic particles, which include the protons, the neutrons, and the electrons, and how those work in terms of isotopes and ions and things like that. And then we did some work on the modern ideas of the atom, where you're looking at things like orbitals and electron configuration and light and how light interacts with things like that. And so just, try and make sure you're looking over all the different notes from this unit. Make sure you're trying to understand all the big ideas, because it's a pretty expansive exam and there's quite a bit of things on this. So just make sure you're prepared as you're going in. So this first one, just a little vocabulary. It says ions are formed by changing the number of, in this case, we changed the number of electrons on here. So it's the number of electrons because protons are in the nucleus, electrons are on the outside. If you are switching to different ions, you have different numbers of electrons. In the movie Our Friend the Atom, the narrator explained that Democritus' theory was discredited by, this was Aristotle. So Aristotle refuted the idea of the atom and got rid of it for a very long time. Rutherford found that the atom was mostly empty space through his experiment with gold foil. An atom's identity determined by its protons. This is super duper important that you know this, all right? One of the most important things. So if you're looking at the periodic table, something's atomic number, the number that's written up above the substance on the periodic table, that's the number of protons that it has. So carbon is number 6, that means 6 protons. Oxygen is number 8, that means 8 protons. So something's atomic number, the way that it gets identity, that's how many protons that it has. Number 5, an atom with a positive charge. This is called a cation, positively charged. 2 oxygen atoms with different mass numbers. Those are isotopes. They have different numbers of neutrons, different mass numbers. All right, an atom with 5 protons and 6 electrons has a charge of -1. This is because protons are positively charged, so you've got like a +5 here, all right, and electrons are negatively charged, so you got like a -6, and so you end up with -1 overall. This one here, all about the different historical models of the atom. Again, this model said that the atom was a mixture of positively charged and negatively charged bits, like a chocolate chip cookie. This was Thomson. It was otherwise known as the plum pudding model. All right, so Thomson is C. Number 9, the model stated that electrons were moving around the nucleus in nice circular orbits. Bohr was the one who thought this, so that is E. This model explained that atoms were all made up of the same material, but they had different shapes and sizes, such as smooth and slippery water atoms or light and wispy air atoms. This is Democritus' idea of the atom. This model was the first to be based on scientific evidence. So this is a big thing here. Democritus was just a philosopher. He just said what he thought his ideas were. He didn't actually have any scientific evidence to back this up. Dalton is the first one of these people who's actually a scientist. So Democritus is not really a scientist. He's a philosopher. He's just a thinker. He just argues about what he thinks things are. But Dalton is the first one to collect evidence. So it's B. All right, number 12, this model is otherwise known as the billiard ball model because it was thought that atoms were hard, indivisible spheres like a billiard ball. That is also Dalton. All right. Okay, going on. This next section we're looking at subatomic particles. So this is how many neutrons are there in boron 12. I've been having a lot of people come up to me and ask me about this, and they say boron -12 is what they think it is. That's not what this is. Boron 12 is an isotope of boron. All right, what boron 12 is this boron with a mass number of 12. So we have boron, and if you look at the periodic table, boron is atomic number 5. All right, boron 12 has a mass number of 12. All right, its atomic number 5 means that it has 5 protons. If it's got a mass number of 12, the mass is made up of the protons and the neutrons. All right, and so it must have 7 neutrons to make up the remainder of the mass. All right, 7 neutrons, 5 protons makes a mass of 12. Number 14, the atom is neutral, no charge. All right, how many neutrons are in the atom shown on the right? So we're looking at this atom on the right. We're looking for neutrons again. It's the same thing. The mass number is 9. The atomic number is 4. It has 4 protons. It has 5 neutrons. How many electrons are in the same atom? All right. Well, it's atomic number 4. That means it has 4 protons. It's neutral, I said. So that means it has the same number of protons and electrons. And so it has 4 electrons as well. Looking through here, it says, this is about the modern atomic theory. It says within any given energy level, which of the following sublevels has the lowest energy. All right. The lowest energy that you go into for a sublevel is S. All right. We enter S first, P, D, and then F. How many orbitals are there in the S sublevel? So the orbitals, you have to there's a set of notes on this where it talks about orbitals and shapes and things like that. S is the sphere. There's only one orbital in each, for the S sublevel. There's only one shape there, all right? It can fit 2 electrons in it, but there's only one orbital for S. How many electrons would fit in the entire second energy level? So this is pretty difficult because you have to think, okay, the entire second energy level. Well, on the second energy level, we have the 2s sublevel, and we also have the 2p sublevel. S sublevels have 1 orbital in them. P sublevels have 3 orbitals in them, 3 shapes. Okay, so you have to think, how many electrons could we fit in the entire second energy level? Well, really this should go up, 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 down, down, down. All right, we have 8 total electrons that fit within the 2s and the 2p. There's no such thing as a 2d. All right, so in the second energy level, we only have S and P. 8 electrons fit in there. All right. 19, which sublevel is represented by the shapes shown to the right? We've got a clover there, and then what I call like the double pacifier shape. All right, so that is d orbitals. S is the shape of a sphere. If you have P, that's the dumbbell or the infinity sign shape. All right, clover or double pacifier, that is the d orbital. Actually, it even says d right here. I didn't even realize that until right now, but it says d right here. They're d orbitals. So that's what that is. 20, which of the following forms of electromagnetic waves has the highest energy? You have to remember the way this goes, all right? It's radio waves, microwaves, infrared, red, orange, yellow, green, blue, indigo, violet, ultraviolet, X-rays, gamma rays. All right, so if we look at all of these, we're looking for the one with the highest energy, okay? Gamma waves is the highest. Low frequency electromagnetic radiation also has, all right, low frequency means low energy, all right? Wavelength is the opposite, so low frequency means long wavelength, all right? That's how that goes. The 2 electrons in an orbital have to have opposite spin directions. So that's just kind of a fact. That's what the up arrow and the down arrow represent. And then this next one says we're going to create an orbital filling diagram for iron. Okay, so here's what we do. You look at the periodic table. You have to look at the periodic table and see where it goes through. It goes through the first row S block. Then it goes through, there's not a first row P block, so then we jump down to second row S block. All right, then we go through the second row P block. And then we go through the third row S block. And then we go through the third row P block. All right, then we're up into the fourth row S block. And then we go into the D block, but remember D drops down by 1, so we end up in 3D. All right, there are 5 boxes there. Okay, and then you have to see where iron is. Within that D block, iron is the 6th element in. All right, so that means we fill up everything all the way through to 3D, up, down, up, down, up, 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 down, 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 up, down, up, 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 down, 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 up, down. All right, and then we have 6 electrons left to work with to get to iron because it's the 6th one in. Or you could just, if you want to go the long way, iron is atomic number 26. If it's in its neutral state, it has 26 electrons. If you count the ones that we have already, we have 20, so we have 6 more. But I think it's easier if you just look at the D block and see that iron, if you count in, it's the 6th element in, so it's going to have 6 electrons in this D block. We go up, 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 and then down. All right, that's 6 electrons. So that is the orbital filling diagram for iron. For chlorine, we need to go through and do the electron configuration. Now, you could make the orbital filling diagram, or you could just think, what is everything that it has to go through? It has to go through 1s, and then it has to go through 2s, and then it has to go through 2p, and then it has to go through 3s, and then chlorine is in 3p. All right, then you think, how many electrons are there? Well, 1s is filled up, so there's 1s2, and then we go through both of these here, 2s2, 2p6, 3s2, and then for chlorine, it is the 5th one in here. All right, it's the 5th one in that 3p sublevel, so there are 5 electrons in there, and that's how we do that. So that is that. Lots of stuff kind of coming at you pretty fast here, but hopefully that gives you a good idea of what you need to prepare for when you're studying for this exam. I'm hoping it shouldn't be too bad, but there is a lot of material, and we've been going over this unit for a long time, so make sure that you really work hard to prepare yourself.